Hey, hello guys, welcome, vanakkam, mandanam, namaskaram. Today we are going to see increasing and decreasing functions. Okay, so otherwise this is also called as monotonicity, part 2 of applications of derivatives. Okay, applications of derivatives. So today we are going to discuss also some NCERT sums. Today we will also discuss some JEE sums, but before that mainly we will be concentrating on NCERT sums because there are about 18 questions and we will not do every problem. We will do models. Okay, models. Okay, so first we will study this word. What does monotonicity mean? Mono means, okay, mono actually increasing and decreasing, increasing or decreasing function. A function, first of all, what does it mean? See, a function can increase or it can decrease. That means, for an example, okay, for an example, you just take it as a graph. This is a very rough graph. I'm going to erase it. For an example, this is your parabola. Okay, this is your x square. Okay, so you are having it like here. For some reason, I cannot even draw a parabola. Okay, okay. Yeah, okay. It is saying that parabola is not looking good, and he can draw better than me. Okay. So here you can see that from this point to this point, okay, from this point to this point, it is just decreasing. Okay, its value is being decreased as you just put x value. Okay, this value is also being decreased. But whereas from here to here in this way, okay, as you put here, the value is being increasing. So here this function, this x square, is actually neither increasing nor decreasing when you take from here to here. But when you take it from here to here, it is decreasing, and here to here it is increasing. Okay, so increasing and decreasing is actually based on the domain. Okay, domain of the function. This is what very basic thing, right? Whether it is increasing or it is decreasing, we can very easily we can say it. Now coming to this word monotonicity. So what does the word mono mean? Mono means single. Okay, that means it should be either downwards. Okay, in a single way it should be. Tonicity. What is tonicity? Mono means single. This we all know. Then what is tonicity? Okay, see here, tonicity is actually representing the pathway. Okay, that means here, see, single, uh, a single curve. Okay, single direction the curve. Single direction, you can see that it is just going like this. Okay, this line. Okay, it need not to be curve always. It should be. It can be straight line or it can be anything. Okay, but it should be having a single direction. So that is what you can see here. It is having just a single direction, and here also it is having a single direction. If in case it is having double direction, that means both upwards and downwards. Okay, so then it is not known as monotonicity. Okay, here it is monotonicity because it is having a single direction. Okay, so that is what monotonicity means. Okay, in point of inflection, well, I will not. Okay, we will also discuss some points of topics about. We will also discuss some points about point of inflection in maxima and minima, not in this part. Okay, not in this lecture. Today we are just going to discuss about increasing and decreasing. That's it. No. Okay, so actually sometimes he can be very aggressive. I don't know why. Maybe it's their hormonal period. Birds have a specific period of time where they'll be very aggressive and they will not be aggressive. Okay, so we shall start. A function, okay, a function f, a function f okay, a function f is said to be monotonic. Monotonic if they are if they are okay, so if they are either either increasing or decreasing. Okay, increasing or decreasing in their entire domain or in their domain. Okay, so in their domain. So that is what I have also given you an example. We shall also take a few examples. Okay, so examples. First example shall be f of x. I'll take a differential here. Okay, so the first example shall be f of x is equal to e to the power of x, and we all know the graph which we have already discussed in our relations and functions. Okay, so the graph is going to be like this. Okay, the graph is going to be like this for e to the power of x, and for logarithmic it is just the inverse graph. Okay, that's it. So here you can see that it is just increasing, and by the way, when you take from here to here it will be decreasing, and when you take here to here it will be increasing. So now you might have a doubt. So which direction should we take? In that case, okay, you can take, if you are taking in both the directions, it will be increasing and decreasing. So which should you be taking? Okay, you should be taking always left to right. Okay, always from here to here. Okay, so that's actually basic common sense. Also, even while discussing in 11th standard, okay, well, I did not take any videos for 11th standard, but we have periodic classification over there also. Mostly we'll be talking about left to right only. Okay, next is tan x graph. Okay, so when you take the graph of tan x, okay, f of x is equal to tan x. See, you are having a graph like this, where when you check, okay, when you just check from left, okay, from left to right. Okay, so when you're checking it from left to right, you can easily see that it is just increasing. Okay, it is just increasing. Now, okay, so this is what actually example for increasing. These two are examples of increasing. Okay, so these two are examples of increasing, and when you take the example for decreasing, okay, the example for decreasing, actually we are just discussing about decreasing, so sorry, increasing, right? So now we will be talking about also decreasing. Okay. So now let f of x, okay, we shall take e to the power of minus x, okay, e to the power of, let f of x be e to the power of minus x. Now what do you think the graph is going to be? It is actually a very basic graph, okay, exact opposite of this. Okay, so the graph is going to be like this. Okay, so this is what for no. Okay, so whereas you can say that it is decreasing. Okay, so when you take it like this, it is decreasing. Okay, Then next graph that I'm going to take is, you all know cot inverse graph, that is also decreasing. Then also we shall take f of x is equal to minus x cube. Okay, x cube graph is very similar. Okay, x cube graph is actually very similar to tan x graph. You can draw x cube graph for tan x graph, and you can draw tan x graph for x cube graph. The one and only difference is here you have to mention pi by 2 plus pi by 2 and here minus pi by 2, but you should not mention that thing for x cube graph. Okay, so that is the difference. Then minus x cube. Minus x cube is actually going to be very similar. Okay, very similar. We will take this graph itself. All you have to do is okay. So all you will have to do is okay. See, the graph for x cube is going to be like this. Okay, where you can see that it is just decreasing. It's just keep on decreasing. Okay, so this is what the basic graph for increasing and then for decreasing. Okay, so then what about see, here you are having increasing and you are having decreasing. Okay, this is what we will be calling it as monotonicity. Okay, we will be calling this is what as monotonic. These graphs are monotonic in nature. No. A function f is actually if a graph is decreasing and increasing. Okay, so which color did I use here? Okay, a function, no, okay, a function is said to be non-monotonic. Okay, non-monotonic if it is increasing, if it is increasing, if it is increasing and decreasing. Okay, okay, is it to be if and decreasing in its entire domain. Okay, so the best example is going to be okay. So this is actually, you can see that this is non-monotonic because this is actually increasing and decreasing also. That's the reason. Okay, So next we are going to see also not only this graph, actually also any quadratic, then also we can take sin x, okay, sin x or cos x, okay, sin x graphs we can take. Well, what about sin x graphs? Wait a second. Here it is, f of x is equal to x square, and then hereby it will be f of x is equal to cos x, okay, cos x. Okay, we will just imagine, see, actually I cannot draw that much. Why can't I? I can't draw now. Okay, so this is your cos x. Okay, so your cos x graph is actually having both increasing and decreasing. So this is also non-monotonic, and also we can take, okay, then what else can we take? We shall take both. Also sin x you can take. Well, this is not sin x graph, but also note that sin x is also, okay, f of x is equal to sin x. That will also count into it. Okay. What's the difference? I'll also draw. Do you know a fun fact? Okay, do you know a fun fact? That if you just change 90 degrees, if you just tilt this side or this side, okay, 90 degrees, then you will be getting sin x graph. Now we are going to do that only. That is actually because of that reason only, even the rule like sin square x plus cos square x is equal to 1. Okay, see, just look. Okay, so this is what my cos graph is. Okay, just I'm going to take it like this, which is 90 degrees. Wait a second, I cannot do it. You know what? Wait, I will draw it itself. Why to have this much confusions? Yeah, well, yeah, like I can do this now. Then actually, I'm trying to prove that. Okay, just 90 degrees is the change. Just 90 degrees is the change between them. See, now you have got sin x graph. Same, just all I have did is I've just changed it 90 degrees. That is a fact. Okay. Then what else? Monotonicity at a point. Now we are really going into it. See, till now all we have did is to draw, is to talk. That's it. Hereafter, little by little, we are going to also take some sums, also some theorems. Okay. So monotonicity at a point. Okay. So what is monotonicity at a point? You have to take the graph. For an example, I'm going to take this graph. Okay, or I can make any graph. Okay, I will take this graph itself. What's the problem? Now, imagine here, and then imagine here. Okay. So let it be a minus h, and then let it be a is equal to h, here by a plus h. Okay, then here what it will be? It will be f of a minus h, it will be f of x, or sorry, f of a, then here by it will be f of a plus h. Isn't it? Okay, isn't it? Okay, so here now we are going to check whether it is increasing or decreasing. Just by looking at the graph, we can very easily say that it is increasing. Now, you know a trick. You can say it as trick itself, not a problem. When a minus h is lesser than a is equal to x is lesser than a plus h. Okay, what are this? Okay, what are these? These all are. Okay, these all are. This I can take it as x1. This I can take it as x. This I can take it as x2. Okay, when this condition is there, then automatically your also f of a minus h should be less than f of a should be less than f of a plus h. Okay, f of a plus h. If this condition is being satisfied, then we can say that the function is actually indeed decreasing. Sorry, increasing. Okay, it is increasing. Okay, it is increasing. Wait. Okay, it is actually known as strictly increasing. See, increasing itself is actually of two types: strictly increasing and just increasing. Okay. We will also talk about what is general increasing and what is strictly increasing later on. Okay. See, next another thing. Yeah, another thing. And also I'm going to give here also one fact. See, now I'm just going to take the same graph. Okay, the same graph with these with this. Okay. Now the fact is exact flip of this graph, that is okay, then negative part of this graph. For an example, the equation of this graph be something. Okay, it can be anything. So hereby it is not anything, it is a cubic. Okay, it is not a cubic, minus cubic graph. Okay, this is a minus cubic graph, plus also some constant. This is also some constant is there. Okay, but this we shall keep it as, okay, this entire term we shall keep it as y. Okay, this is minus cubic graph plus x. Okay, plus k. This is okay. I think that is what the graph is. Okay, for cubic graph you will be having like this now. Wait. 1 second. No, this is plus cubic graph only. This is plus. Okay, plus cubic graph plus some constant. That means, okay, this is what it is. Let it be y. Then the negative, if you are willing to draw the graph of this negative portion, well, this k will be plus only. You cannot change that, because with respect to this k only, this point will be. Okay, with respect to this k only, this point will be. But this graph you can change. Okay, this graph you can change. That is going to be negative cubic graph. Okay, negative cubic graph. Here, if it is plus now, here it is automatically negative, isn't it? Oh God, wait. I'm going to check it. Whether whatever, like this now. Correct. Okay, whatever I've said is correct. Okay, exactly. That means hereby it is going to be minus y. If a graph, okay, if the equation of this graph is actually plus y, then the equation of this graph will be minus y. See, here, then it will be decreasing. For plus y, if it is increasing, then for negative y, it will be decreasing. So, all you have to do is to multiply negative sign to that. Okay, all you have to do is to multiply the negative sign to it. Then automatically anything will be converted to, okay, the other monotonic. That means increasing, okay, increasing graph can be converted into decreasing graph if you multiply minus to it. Okay, if you multiply minus to it. Okay. Okay, so this is just something that came into my brain. Okay. Now hereby you are going to take same points. Okay, hereby you are going to take same points. Let it be a minus h. No, this is going to be a plus h. No, a minus now. A minus only. A minus h. Then let it be a. Then this is b. A. Let it be a plus h. Okay. Then what about their respective values? This point. Okay. Now, okay, let this point be x1, x2. Okay. Hereby, the exact same condition is going to be applicable. Okay, the same condition is what even we are applying here. But here f of x. See this thing. That is what very important. Okay, wait a second. Okay, so then here you can see that f of a plus h is the least. F of a plus h is the least. It is what very in the bottom itself. F of a plus h only you are having should be okay. Then f of a, then f of a minus h. Here f of a minus h was the thing that was having the least value, but whereas here f of a minus h is the thing that is having the highest value. That is the difference between this and then this. Okay, so we can call this graph as strictly increasing graph. Then we can call this graph as to be strictly decreasing graph. A strictly decreasing graph. So that's the difference between this and then that. Okay, so shall we do some fun problems? Okay, well, anxiety problems are not that much fun, but the problems that you are doing based on these graphs are there, right? Those all are very good to do. Like all you have to do is you have to see them within just seconds, like maybe 1 or 2 seconds. You can very easily identify whether it is increasing or decreasing. Okay, so we should give some work to our brain. We should have a graph. Okay, well, see. Okay, so they have given us 3 different points. They have given us 3 different points. Okay, let it be this. Okay, let it be this. Then I'm going to conclude this. Then this. Like here, then here. Okay, so it will be A minus H, it will be A, it will be A plus H. Okay, so here. I will also write that. Okay, I will also write this, what I said. Increasing is equal to negative of decreasing. Okay. No one will be saying you this. If they think, they will be saying, okay. If they think, then so the thing is, all you have to do is you have to just map these dots to the x-axis, okay, to the x-axis. Then you can very easily say that it is an increasing, okay, it is an increasing graph, and that too not just increasing, it is a strictly increasing graph. Okay, it is strictly increasing graph. What is increasing and what is strictly increasing? Very simple, very simple, very simple. I hope actually I can remember this graph. I don't know whether it is this correct or not, but in 9th standard we studied a concept called as latent heat. Okay, latent heat. Over there they have given us a graph. I think that graph is that graph was going maybe linear exactly directly, or I don't know, but there was some graph like this, but something similar. Okay, that's 9th standard chemistry concept. Now we will come here. You can see that it is going like this. Okay. Here it is just increasing. Here you cannot say it as strictly increasing, because these points, because of these linear lines, whenever you are having a linear line or whenever you are having a line that is parallel to the x-axis, you cannot say that as linear line. So you cannot say that as strictly increasing. See, so but when you are having a line that is parallel to y-axis, then you can say that as strictly increasing. Okay, when you that you can say no. Actually, this also you cannot say it as strictly increasing, because it should be having some slope, it should be having some vertical slope, because you can say it as also decreasing, right? You can also say like this, okay, or you can say it as this, okay, you can say it as both, but here you cannot say like that. Here it is just increasing. So I will also come to just that point, but before that we will just do this sum, then we will come here. Wait. Okay, let this be one point, let this be one point, then let this be another point. Okay, so you can see that these 2 points are actually equal, but here it is not like that. Okay, so hereby the condition like this, okay, the condition like this will actually be having all the one and only change is f of a minus h is going to be less than or decreasing, less than or equal to f of a, which is going to be less than or equal to f of a plus h. This is actually for increasing. Okay, so this is actually for increasing. So you have to put here just equal to sign. Okay, all you have to do is you have to put here equal to sign. Okay, so when there is equal to, then it is just increasing. Okay, when there is equal to, because of this equal to, now this is just increasing. Okay, so it is decreasing. Because of this equal to, now it is decreasing. Okay, now here also if you are putting equal to here and then here, then now these two are increasing. Okay, here it is not strictly increasing, it is just increasing. There is difference. Okay, there is difference between strictly increasing and then just increasing. So this you will have to note. Okay, done. Pakka, super good. Okay. So this is what the thing is. Okay. Now we will come here. Okay, so and if you want the graph, okay, for just increasing, see this is actually increasing. If you want the graph for decreasing, what you have to do? Just multiply minus sign, then it will become like this. Okay, then it will become like this. Then that's it. You have got your graph for decreasing. All you have to do is you have to multiply minus sign. That's it. Very simple, right? Now you come here, now you just come here. See, here actually this is hollow circle, hereby it is hollow circle, here only it is fully circle. So that means this point only I will have to take equated to y-axis, here also equated to y-axis, here also you have to equate it to y-axis. Then will be what will be f of a minus h, will be then f of a plus h, sorry, a is equal to h. This will be a plus h. Okay, so now f of a minus h is actually less than, okay, less than f of a, which is also less than, okay, f of a plus h. Okay, so now hereby you can say it as strictly increasing, and also from this we can also give another conclusion. What is that conclusion? A very important conclusion, by the way. Okay, to be strictly increasing or to be strictly decreasing, okay, or to be increasing, to be decreasing, you need not to have it as differentiable. Okay, the function need not to be differentiable and it need not to be continuous. Okay, it need not to be continuous or differentiable. Okay, so to be just increasing or decreasing, the function need not to be continuous. The f of x need not to be continuous or differentiable. Okay, or differentiable. So here you can see that it is not at all continuous. Okay, here it is not continuous. If it is not continuous now, actually here it does not have a limit at this point. Okay, so it is not continuous, and also it is not okay, it is not differentiable. Okay, so then also we can say here it as, we can also say here it as, see, for not differentiable I can give you another example. That is what this graph is. I have given you this now. Hereby you can see that here it is all having sharp corner. So that means it is going to have two different tangents. So because of two different tangents, because of not having a unique tangent, here it is going to be non-differentiable. Okay, so but even though it is non-differentiable, this is an increasing function. Okay, this is an increasing function. Now, very important thing. Okay, this is actually problem solving tool, a very important thing, and this is also a problem solving tool. What am I writing on you? Problem solving trick. I don't know why did I put there M. Actually thought to stop it with PROM. That's problem. Okay, so but it is having a different meaning. It is prom, and prom is having a different meaning. Okay, so hereby you can see that f dash a, if okay, you are having a function. For an example, you are having a function like f of a. Okay, this is also a function. Every graph is a function. Everything is a function in this world. Okay, so that one, here you are having f of a. Okay, f of a is your function. Now you are differentiating it. Okay, now you are differentiating it. Okay, so you are differentiating it. You can have two different possibilities. Okay, you can have two different possibilities. What they can be, it either can be positive or it can be negative, isn't it? Okay, so you are having a function f of, okay, so f of a you are having, hereby you can have f dash a and then another f dash a. Okay, so here it can be either positive and it can be also negative. Okay, negative. Okay, so it can be positive, that means here it can be greater than 0, and then hereby it can be less than 0. So 0 is greater than this. Okay, so I'll write here this side itself. Okay, so these are your two different conditions, and also we'll be talking about what if it is equal to 0, what if f dash a is equal to 0, that also we'll be talking. Okay, now you come here. Okay, so then it is known as, then in at, okay, then at this point, okay, at this point it is actually increasing, so which color? This color. Increasing, and then this is going to be decreasing. Why is that so? Why is that so? You just take a graph. Okay, you just take a graph. What is f dash? What is f dash a? This is a slope. This is slope, which we have already discussed. This is slope, right? So that means you just take this part, you just take this part, you just neglect this part. So slope for this graph is going to be like this. So if your f dash a is actually less than, okay, if your slope is negative, what is this slope? Okay, f of f dash a is slope. If this is negative, then automatically it is going to be like this only. So whenever you are having a slope like this, then automatically the direction here, this is also going to be downwards, okay, towards downwards only. So this is going to be decreasing automatically, decreasing. Then you take here, this is your f of a, okay, this is your next part of your f of a. So here, if in case your slope, this is what slope now, okay, your slope is this one, okay, I know I'm very horrible in drawing, but slope, the tangent, okay, this is what it is. So hereby you are having f dash a as positive, okay, here it is positive. So if it is positive, then that means the direction is going to be like this. So that is why your slope is like this. So here that is why it is increasing. It is increasing. This is the reason why it is increasing and decreasing. Okay, so it is actually not entirely, it is not increasing at this point. Okay, at x is equal to a. Here also at x is equal to a. Okay, so shall we do one problem? We shall do one problem. See here how basic questions we have. So amongst this, which question shall we take? Shall we take this question? Okay, find the intervals in which the function f given by is increasing, okay, and it is decreasing. So we will have to find the interval. Okay, no, this first we'll find the is increasing. Show that it is increasing or decreasing. This we will do first of all. So you have got this, that is 3x plus 17. Okay, 3x plus 17 is equal to f of x. Okay, is equal to f of x. On or, okay, so in its entire domain you will have to check whether it is increasing or not. So now you will have to find f dash, okay, f dash x, which is going to be 3, okay, which is going to be 3. This f dash is going to be 3. So f dash x, okay, is greater than 0. Okay, it is a linear function. It is a linear equation, or it is a linear equation. Yeah, this is a linear equation, not a quadratic equation. This is a linear equation. When you differentiate a linear equation, you will be getting a constant function. So 3 is a constant function, and always 3's graph is going to be like this. Okay, 3 f of dash x, okay, is going to be like this. So here you can see that it is a constant function, and automatically it is going to be like this. So you are going to have this is actually greater than 0. So f dash x is greater than 0. So whenever it is greater than 0, that means what? It is greater than 0 now. It is increasing. Okay, so it is increasing. Then we will also take this sum. Okay, that is, see, they have given this as our f of x. Okay, this is our question number 2. Okay, and also in its entire domain you will have to find. So that means f of x is equal to e to the power of 2x. So then f dash x is equal to 2 into e to the power of 2x. Okay, 2 into e to the power of 2x. So this one is going to be always positive. Is also here also is going to be always positive. Why is it always positive? Why is it always positive? Because what does it mean? Okay, what does it mean? See, E is actually a constant. E is a constant. It is actually known as Euler's constant. Okay, Euler's constant. ERS. Okay, EULERS. Euler's constant, which is going to be 2.718. Okay, 2.71845. Even in our biological book, they have given. Even in our biology, organisms and population, they have given in the graph of in the graph. They have given. Also, they have given us integration and differentiation in biology. So even for biology, some mathematical knowledge is required. Okay, so this is what Euler's constant is, and that means what? It is 2 into 2 to the power of 2 to the power of x, and we need not to take care about this x, no matter whether this x is positive or negative. Okay, if it is negative also, even if this x is negative, this entire term will be positive only. Even if this x is positive, then also this entire term will be positive only. So this is actually greater than 0. This is the reason. Then you take your third question, f of x is equal to sin x. Okay, so if it is equal to sin x, then that means what? Okay, so f of x is equal to sin x, then your f dash x is going to be cos x. Okay, positive cos x. Now they have given us, okay, we have to prove it is increasing here in this, and then we have to prove it decreasing here. Okay, and if you are able to prove here itself, then we can very easily say that it is neither increasing nor decreasing in this, because in this domain, okay, in this domain it is increasing, in this domain it is decreasing. Then automatically when you combine these two domains, the union of this and this, that is, okay, well, they have given here open brackets only. So the union of this and pi by 2 comma pi is what? 0 comma pi. So the union of these two domains, and also note this is also a very interesting point, that is, when you are having two different domains, with this domain, okay, increasing, okay, this is with this domain increasing and then this domain decreasing, when you unite, okay, when you do union for these two domains, then that will be automatically becoming as increasing. But when this is also increasing and this is also increasing, just for a case, okay, in the next case, if this is also increasing and then if this is also increasing, and when you do union for these two, then here also it will be increasing only. Then here you are doing decreasing, okay, and here also you are here also in another domain also there is decreasing. When you do union, then that will be giving you decreasing. So here by this case 1, so case 1 is actually this easily we can prove if you are able to prove this and this. Now we will prove that. Okay, so f dash x, okay, f dash x is equal to cos x. Okay, so cos x, I have already given you that basic thing, okay, that basic variable in which quadrant cos x is going to be positive, negative, in discussing the formulas for trigonometry. Okay, so this is going to be first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, so here all trigonometric functions are positive, here only sine is positive. Okay, that means here cos is negative. Okay, so here by it is 0, here it is 90 degrees, here it is 180 degrees. Okay, then here it is 270 degrees and here also 360 degrees. Okay, so the first condition is that it is 0 to 90 degrees. So 0 to 90 degrees cos is positive, so that means f dash x, okay, f dash x for this interval it is greater because cos is positive, so that means sin x, this function is increasing. Okay, next is 90 to 180. Here cos is negative. Okay, it is second quadrant. So since it is negative, you can very easily say that here it is decreasing. And also by looking at the graph also you can very easily say that it is decreasing. So now you are uniting this and this, then you will be getting this. That's very simple, right? Okay, now we will be doing next sum. Okay, we'll be doing as much as possible. Find the intervals in which, okay, the function f, okay, this is for the function f, okay, we have to find in which interval this is actually increasing and then this is actually decreasing. Very easy. Maybe this might be looking like a kind of different question, but this is such a simple problem. Okay, so here this is what your f of x, then your f dash x is going to be what? It is going to be 4x minus 3. Okay, this is what your f of x is. Okay, so that means you will have to now equate it to 0. For questions to find intervals, what you have to do is you will have to equate it to 0. So that means f dash x is being equated to 0. So actually this is something we will be calling, when you are equating something to 0, when you are equating f dash x is equal to 0, then you will be getting x, okay, value of x. So when you are equating it, 4x minus 3 is equal to 0, then you will be getting x is equal to 3 by 4. Okay, when you are doing like this, then this value is actually known as critical point. Okay, critical point, very critical topic this is. Okay, very critical note point this is. In maxima and minima we'll be studying a little bit in depth. Here we will not be studying that much, but note that it is known as critical point. Okay, now all you have to do is plot a graph where 3 by 4 is there. Okay, 3 by 4 is there. Okay, so you are having 3 by 4 now. X is equal to 3 by 4. So this is going to be positive. Here it is going to be negative only. Absolutely. Here it is going to be positive. So anything, okay, positive and then negative. So negative infinite to 3 by 4. When you are taking now, then it will be decreasing. It will be decreasing. Okay, then 3 by 4 to positive infinite. Now then it is increasing. Okay, then it is increasing. Okay. Which question are we doing? Huh. Okay, so that's it. This is also correct. I just got out. It is correct only, everything. Okay. Next is, see, same thing only we'll have to do, and as I said that, when you are differentiating a quadratic equation, you'll be getting a linear equation. When you are differentiating a cubic equation, you'll be getting a quadratic equation. Okay, so and when you're differentiating it, you'll be getting a linear equation. Well, you will not get this. Okay, you will not get this. I'm just saying that. Okay. Then, okay, this one we all can do. Okay, this one is also, see, in every case you will have to equate it. It's f dash x. Okay, it's f dash x is equal to 0. Then you can very easily find. We will also do some other sums also apart from this. Okay, no, we will stop here even because like you can see that everything is very simple and very easy. Like all these 6 questions are of same model, not all these 6. Okay, well, first 3 are same model, then these 3 are same model, the 7 is not same model. Okay, by the way, whenever I'm doing sums, okay, that too whenever I'm teaching sums, I will be getting a memory. When I was studying 7th standard, it was online class. Okay, I was in online class. 8th standard also, most of the part it was online class. 6th standard it was in online class. So 7th standard I will not listen to any classes. YouTube. I'll be watching YouTube. Whenever my parents, even they know, okay, now they know. Whenever they come, what I'll be doing is we'll be changing to class itself. So my knowledge in every subject was very weak. It was very weak, really. Automatically, okay, now most of us were doing like that. Okay, so since it was very weak, I didn't know anything about mathematics. Okay, that was about these equations. My father will be scolding me, will be beating me, okay, because of doing all these equations very wrongly. What I'll be doing is, I will not change the signs when I take it from left hand side to right hand side. Okay, I will not divide, sometimes I will not multiply sometimes. So that's the problem. Okay, so whenever I'll be doing the equations, now I'll be laughing at that whole time because now I'll be teaching him differentiation. Okay, sometimes it happens, I'll be teaching him differentiation. Well, he doesn't want that knowledge, but whenever he does wrong, I will be like scolding him. And also he's an engineer, so I'll be taking it as an advantage. Okay, so now here we will be doing this. And also, if I'm doing equations good, that, well, now it's very basic thing, okay, making it negative, positive, all is very basic, but if I'm doing it correctly, then all the credit goes to my father. Okay, so coming to here, which question, our 5th question, so you will have to take f of x, now you will have to differentiate it. F dash x is equal to 6x squared minus 3x minus 36 plus 0, okay, so that's it. So this is what your f dash x is, so equate it to 0. And also what you can do, you can take, wait, when you are equating it to 0, then x square minus 3x minus 36, 1 second, I'll check it correct. 7 to 6 now. 6, 6, 6. Okay, here you are getting 6 square. Yeah. So I'll write here itself for one time surety check. F dash x is equal to 6x square minus 6x minus 36. Okay, so now you will have to equate it to 0, and while equating it to 0, what you can do, you can divide it by 6. So then it will be x square minus x minus 6. Okay, so now you have to factorize it. Minus 6 minus 1. We can take what as common. 5. Sorry. How will 5 come? 6, 1. Okay, so minus. Okay, yeah. Minus x and then plus 1 you can take. Okay, minus x and then plus 1 you can take. So that means you can take x square minus 6x plus x minus 6. Okay, this is what it is going to be. So now you can take x is common, so x plus 1, then minus 6, so x plus 1. So okay, so now we have got x plus 1. Okay, x plus 1. So yeah, now that means what? X is equal to 6 then minus 1 at these points. Okay, plus x and then minus 1, at plus x and then minus 1. Yeah, see, this is what your critical point. Whenever you're factorizing, if you are getting minus x and then plus 1, then that is what your critical point is. But to prove, I've written like this. So this you will have to map. Okay, so that you will have to map. So map it. Okay, so plus 6 minus 1. Okay, so automatically it is going to be plus minus plus. But note, there are some times where this will be changing. That thing is there now, that wavy curve method we have, right? So that thing will be changing. So that you will have to note. Okay, so check this. Okay, so take this. That is, we will be writing it here. X plus 1. Okay, first we will check whether it is correct or not. Any number greater than, okay. Any number lesser, this is okay. Well, here it will be negative only. There it is also going to be negative. So it is going to be positive. Okay, this is correct. There are some times where it need not be always positive, negative. There are exceptions. Okay, there are some sums which will not be always having positive, negative. It might have positive, negative, positive, negative, like that. Okay, or positive, negative, positive, positive, like that also it can be. Like, that's not fixed. Okay, that sequence is not at all fixed. But most of the cases will be having like this. So where at all it will be increasing. Minus infinite comma minus 1 union with 6 comma infinite, it will be increasing. Then minus 1 comma 6, it will be decreasing. And it will be increasing. And if you want me to draw the graph, then the graph will be like this: increasing, then decreasing, then increasing. Okay, by the way, in extreme mass, that means in the next topic we will be studying about minima and maxima. Okay, so this point, okay, whichever is high, that is known as maxima, whichever is less, that is known as minima. Okay, and we'll be calling it as global minima, local minima, and in this we'll be calling it as local maxima. Maxima and minima itself is actually of two different types, local and global. Everything we'll be studying in the next lecture. Okay, so here you have to do exactly the same thing. Everything is very easily. See, even they have given us they have done a help for us. What have they done? They have factorized. So yeah, then seventh question is actually kind of different, I think, but here I don't have seventh. One second. Show that f of x log x minus. Okay, so shall I write the sum? Or I'm kind of feeling lazy to write the sum. Just give me, no, seventh question I do have, I think. No, eighth only I have. Seventh I don't have. Seventh. Okay, so hereby I have seventh that is show that y is equal to, so we have got our equation. Well, just because this is looking like kind of weird, okay, from other sums, it doesn't mean that it is very tough. Well, I have not seen, believe it or not, I have not even done any one of these questions till now. This is the first time that I'm doing every question, okay, from the beginning. Like already we have done 1 to 6, right? Everything is the first time for me doing. Also, this is also for me first time only. Even I have not yet looked in the answer key, but I have here answer key, because if in case something is wrong, or if in case I'm having some doubts now, then I will have to take it, isn't it? Like, because I cannot teach you wrongly. I cannot give this seminar in a wrong way. That is why. Here we will have to show that, okay, y is equal to log of x plus x minus 2x by x plus x, where x is actually always greater than minus 1, is increasing function of x through its domain. And here it's very easy question, okay, just because they have given some conditions like it doesn't make it has to be kind of hard, okay, it does not. So what is our f of x? Our f of x is equal to y is what f of x, okay, is log of 1 plus x, okay, minus 2x by 2 plus x. So differentiate it, that is f dash x, okay, that is f dash x is equal to 1 by 1 plus x into 1 minus 2. See, here you have to use that rule, okay, that denominator, that fractional differentiation rule. That is, first you will have to differentiate it, so then you will be having this, then minus, okay, you will have to then differentiate this, then it will be 1 into 2x, very simple only, okay, whole divided by, well, actually there is a thing, 2 plus x the whole square, okay. Once again, my sir has taught a shortcut trick, whether I'll be checking it whether here only it will be applicable or not. 4 plus 2x minus 2x, okay, divided by this, we will be checking it later. 4 plus 2x minus 2x, cancel, then we have here 4. So what he said is, when you are having a simple thing like this, okay, then the differentiation is, first you have to differentiate it, then square it, then here also square it. Okay, well, we shall not take any, problems, okay, so you also check it like this, but for simple things it will be applicable, okay, for very simple differentiations, or very simple fractional differentiations, it will be applicable. So here it will be 4 by 2 plus x the whole square, 2 plus x the whole square, it will be 4 by x square. Now I check why is this hard, okay, because of that. F dash x is equal to 1 by 1 plus x minus 4 by 4 plus x square plus, who's that, 4x, okay. So we shall actually solve it, okay. See, where will it be 0, it is actually going to be, here one thing we have to be very sure, minus 1, okay, and here it is minus 1, and here x should not be equal to minus 1, because if it is equal to minus 1, then it will be infinite. So, which automatically makes it as, okay, so also we will be solving this, okay, so we should also cross multiply this and that, so that means let it be here like this itself, then at last we will be taking out, okay, plus x the whole square. So this can be written as 2 plus x the whole square, okay, minus 4 into 1 plus x whole divided by 1 plus x into 2 plus x the whole square. Okay, so you have got this. Now we will again simplify this. Okay, I'll erase this because of no space. Okay, so is equal to f dash x, is equal to f dash x. So that is going to be 4 plus x square plus 4x minus 4 plus 4x whole divided by, okay, here the same thing only will be getting, the same thing into 1 plus x we have to do now. So we will just write it here by, okay, 4 plus x square plus 4x, okay, then multiply it with 1 plus x, okay, when you multiply it all with 1, same one you will be getting, plus 4x plus 4x plus x cube. Wait, why are we doing like this? First of all, why are we doing it like this? Whenever it is in factorized form, then only it will be very easy for us, right? Okay, now you check here, here it will be, it cannot be negative, this portion will never be negative, okay, and also here it will be negative, here it cannot be negative, here also it can be negative, okay, so that means what are they asking is actually increasing throughout its domain. Here and here only we might have some problems. Great. Okay. Did we do something wrong? This one, okay, this one you will also write it again. You will actually write it again. This one also. So 2 plus, wait. First, f dash x is equal to 4 plus x square plus 4x minus 4 minus 4x. Now I get it. Okay, now I get it. Okay. This is why answer key should be near to me, because I can check it, cross check it. Now we have got, see, now you will have to equate it to 0. So that means x is equal to 0, then x should not be equal to 1, minus 1, and then x should not be equal to this thing we have. Okay, yes, this thing and this thing you need not to care. See, if this entire thing is actually positive now, then that means what, it is increasing, okay. So always we know that, you can write under, we know that, okay, x square comma 2 plus x, okay, 2 plus x the whole square, now this is 2 plus x the whole square is always positive. Then you take, okay, x is equal to minus 1 is the only place where from this, okay, that means from minus infinite to minus 1 only, in this domain only this function will be decreasing, but here there is no domain. Here you can see that that domain is not there, okay, here you can see that that domain is not there, so which automatically makes this as entirely increasing, so this function from minus 1 to plus infinite will be always increasing, okay, will be always increasing. This is a method. Or second method is where you can actually draw, you can plot the graph, then also you can do like that, but that is very hard, and like how, see, you will have to know to plot the graph for log of 1 plus x, that you will have to know. If you know now, then okay, you can do it like that itself, and if you don't know now, then you can go it by this way. Okay, so within that I have taken 1 hour and 8 minutes. Okay, so then come here, that is find the values of x for which y is equal to is increasing in its function. So this is actually very simple. This will be always increasing, but they are asking us to find this is an increasing function. We find the values of x. For y is actually increasing, we will have to find the values of x. All real numbers, I think the answer is, I think, okay, I don't know the answer. So now we will be checking it. Okay, so y is equal to x into x minus 2 the whole square. Now you will have to differentiate it and it will be 2. Okay, now I get it. Okay, now I get it. So it cannot be all real numbers, no? Yeah, it cannot be all real numbers. So we will have to just first we will do this. Okay, then also you will have to okay, so we will have to then you will have to differentiate this. So it will be x minus 2 into plus x into 1. Okay, so it will be 2 into x square minus 2x into x minus 2 plus x. Okay, plus x. So that means it will be 2. Okay, so you can take 2 common from here, it will be 4. Then 4 you can take it as 4. Okay, x square minus 2x into x minus 1. Okay, so that means x is equal to, at x is equal to plus 1, that's the point. Then at x is equal to here. Okay, this is also easy only. Here I can take x common now. Here I can take x common, right? So if I take x common, here there won't be any x, but here x will be there. So then that means here wait. And also x is equal to 0, that's a point where x will be 0. Then also at x is equal to plus 2, that's also a point where x will be 0. So now plot the graph. So you will be having 0. Okay, you will be having plus 1, then you will be having plus 2. Okay, now you have to check. Okay, see. Here. First. Okay. For greater than 2 now, here it will be always positive, here also will be always positive, so positive. Then here also will be always positive. Then secondly, for less than 2. So for less than 2 in sense, here you can see that here it will be, but greater than 1. Here it is greater than 1. So here it is positive. Hereby it will be positive. But here and here, okay, here also it will be always positive, but here it's not like that. Here it will be negative. Okay, so hereby it is negative. Then here for less than 1. So less than 1, but so we will take 0.5. When you put here 0.5, it will be minus 0.5. When you put here also will be minus 1.5. When you put here, it will be positive. So here again it will be positive. Less than 0. So here it will be negative. Here it will be negative. Here also it will be negative. Okay, for an example, put minus 1. Okay, here will be minus 2. Here will be minus 3. Here it will be minus 4. Okay, so everything will be minus. So here we will be having like this. So automatically for what they have asked, so for the values of where will be increasing is actually 0, 1 union with 2, plus infinite. Okay, is plus infinite is the place where it is increasing function. It is an increasing function. Then after this, prove that y is equal to 4 sin theta by 2 plus cos theta is an increasing function of theta is, okay, so first you will have to differentiate it, then you will be getting y dash is equal to 4 cos theta into 2 plus cos theta, okay, then minus 4 sin theta into minus sin theta, okay, whole divided by 2 plus cos theta the whole square. Okay, so now only we are in 10th sum, still we have to do some sums. Okay, so y dash is equal to 8 cos theta plus 4 cos square theta, minus and minus will become plus. Okay, it will become 4 sin square theta. So when you take this entirely will become as 4. Okay, it will be just 4 cos theta. Okay, divided by so this will be what, 4 plus cos square theta plus 8 cos theta. Okay, it will be, wait a second. So this denominator will be always positive. No matter what. So we will keep it as 2 plus cos theta itself. Okay, we will keep it as 2 plus cos square theta itself. So this will be always positive no matter what. But this is not like that. Okay, where cos theta plus 4 is not like that. depends, but the maximum value of cos theta, is actually sorry, the most minimum value of cos theta is actually -1 only. Even if you put here -1, it will be what? It will be 3 by positive. Okay, but whereas 3 is also positive, okay, 3 is also positive. Or if you are not satisfied, see, 0 to 90 degrees. Okay, that means what? It is first quadrant. Okay, 0, 90 degrees first quadrant where cos is positive. So, but here cos is positive. So that means from 0 to 1, it can be any value. So this entire term will be positive. So the ninth question is positive. Okay, so what I said only, even they have said, I thought there will be some extra points, but no. Okay, but no. 10th question at least do I have? Here we have. Okay, so 10 to 16 we have proved that logarithmic function is an increasing function. So log, okay, so y is equal to, okay, y is equal to ln x, okay, ln x. So, or even you can keep log x, okay, where y dash is equal to 1 by x, okay, is equal to 1 by x, okay, and then, okay, for this function where x is equal to at 0, okay, at 0 is the point, it will be equal to 0, but here it should not be equal to 0, so in domain it's not there, so hence it is an increasing function, because no matter what value you give from 0 to infinite, okay, it will be always positive only. So y dash is actually greater than 0, so hence it is increasing function. You can say just like that. Okay, then actually I'm very hungry, that is why I'm talking like this. I have to go and eat. Okay, there is chicken gravy and rice for me. Prove that the function f given by f of x is equal to x square minus x plus 1 is neither increasing nor decreasing at this interval. Okay, so f dash x is equal to what? 2x minus 1 is what your interval is. So you take it, okay, you just take it. X is equal to 1 by 2. So you just plot here 1 by 2. Here 1 by 2. Here will be plus, here it will be minus, right? Okay, so because greater than 1 by 2, any number you take, it will be always, yeah. Okay, correct only. So you can see that there is an oscillation. Here it is decreasing, here it is increasing. So there are two different things. So and here it is, but what have they given? They have given us minus 1 and then they have given us plus 1. So minus 1 to 1 by 2, it is actually always decreasing. From plus 1 by 2 to plus 1, it is actually always increasing. So you can see that both increasing and decreasing is there. So hence it is neither increasing nor decreasing. Okay, that means it is not monotonic. Okay, it is not monotonic. Then which of the followings are decreasing on? Okay, you will have to, very simple, you can just differentiate it, then just look at that. Okay, so the answer is okay, u. Because see, what is the differentiation of cos 3x? It's going to be minus sine 3x. Okay, minus 3 into sine 3x, and sine is positive here. So option C is the answer, I think, but it's all mind calculation. Option. Wait. We will do everything very slowly. So here, here. See this guy is actually decreasing. They're asking here. It is decreasing. They're asking now. Okay. So you just check minus sin x. Okay, minus sin x is what your f of x. Okay, f of x, and that here in this particular quadrant, which is the first quadrant, all trigonometric functions are positive, which is from 0 to 90 degrees. So which means automatically here there will be positive. Okay, but here there is negative, so it will be giving you negative. So f dash x is actually less than 0, so hence it is decreasing. So you are 1. Okay, so you are 1. So you are one answer. Then you also check here. Cos 3x into 3 is what equal to f dash. Sorry. I have taken another thing now. So minus 2 sin x sin 3x. Okay. So sin 2x. Why am I taking that? Why am I taking this? Okay. First differentiated minus. Okay. Perfect. So exact same thing only. Okay, so here also it is actually decreasing. But here they have given some explanation for this. Actually, there will be a change. Okay, okay. I got. Okay, okay, okay. See, here it is x, and they have given us is actually this is what x. Okay, but for 2x, see, x belongs to 0 comma pi by 2. Okay, but whereas 2x belongs to 0 comma pi, 0 comma pi, and 3x belongs to 0 comma 3 pi by 2. Okay, and then x belongs to again. See, yes, yes. Okay, so second, and this is the reason, and then this is the reason why cos 2x is actually negative, because when you differentiate, what we will be getting? Minus 2 sine 2x you will be getting, right? Okay, so which means 2x is actually belonging to here, 0 to pi. Okay, and 0 to pi, sine is positive, so that is why this is decreasing. But 0 to pi by 3, in this from 0 to pi only it is positive, whereas from pi to 3 pi by 2 it is negative. Okay, it is negative. So here it is both increasing and decreasing. That is why this one comes. And also this is x now. This is x, right? So sec square x. Okay, so sec square x, all trigonometric, all trigonometric. Here it is increasing. Here it is strictly increasing. Yeah, this is actually strictly increasing. That x graph itself is strictly increasing, right? Okay. Now next we will be taking. Okay, we shall we just end it. Okay, we will just check. Okay, still how many are we having? Even there are still some other points that we will be seeing in part 2. Okay, so with 13 sum we shall end. On which of the following intervals is the function f given by f? This you have to see. Okay, is decreasing. So in which interval is this decreasing? So just f dash x you first find. Okay, what is f dash x? What is f dash x? It's going to be 100 x to the power of 99 plus sine minus cos, okay, minus cos x. That's it. So here by which is the function that it is decreasing. Okay, so for an example, when you put 0 to 1, when you put here 0 to 1, here it will be always positive. Okay, here it will be positive. That you need not to take. Here for this one, here it will be positive, but here what about? Okay, what about here? Is that radians then? Because to put 0 to 1, here it should be inverse. Here it should be inverse. Maybe it can be radians. Or degrees itself. Okay, that's not a problem. Actually, here they did not even conclude cos x for this one, and hereby they did not conclude for these two, they did not conclude this one. Okay, so we will also do the same thing itself. Okay, so here by cos, so what is this? This is second quadrant. Second quadrant like cos is negative, so that means here it will be positive. So the entire term is also positive. So here it is also increasing. So it is what? It is the first quadrant. First quadrant is what? First quadrant is what? Okay, so first quadrant is what? Okay, so first quadrant is where cos is actually positive. So hereby it will be negative. But the maximum value of cos itself will be, so the maximum itself is 1 only. So from this only 1 will be going. Okay, from this only 1 will be going. So okay, so even that cannot be the option. So option D is the answer as they have given. When D is the answer. Okay, next, for what values of A function f given by f of x is equal to is increasing on? So you have to put here value. Okay, so that value should make this function increasing in this particular interval 1 comma 2. Okay, so what will you be doing? What will you be doing? It's actually f dash. Okay, f dash of x is equal to 2x plus a. Okay, plus a. So here you have to equate it to 0. So so x is equal to minus a by 2. So at this particular interval it is equal to 0. Now we will plot a graph. Now we should plot a graph. See here they have given it is increasing in this particular interval. That means this is greater than it is greater than 0. In this particular interval it is greater than 0, where x is actually 1 to 2. So you just put there minus 2x is a. Then they have given that particular interval. In that particular interval it is entirely negative. So so the answer is A can be from minus 2 to minus 4. A can be from minus 2 to minus 4. Is it correct for 14th? Minus 2 to minus 4. Yeah, they have given minus 2 only, but what about minus 4? Okay, see, okay. The minimum value of x is what? The minimum value of x is actually 1, right? Okay, so the minimum value of x is actually 1. See, what are they given? That here it is increasing. So f dash x is actually greater than 0. So 2x plus a is greater than 0. So now that means what? Here, which means that here it will be 1. The minimum value, okay, at x is equal to 1. At x is equal to 1. So it will be 2 plus a is greater than 0. So then that means a is greater than minus 2. Okay, so this is the answer. That is the answer. Okay, then let I be in any interval disjoint from minus 1 to 1. Prove that. Okay, I'm very hungry. We will we will continue from 15 to last 3 sums in the next part. Okay, increasing and decreasing is kind of big. Okay, still now we have not yet completed. There are some other exceptional cases. Here in none of the case where f dash x was equal to 0. In none of the case where f dash x is equal to 0. Okay, we will have to do also some sums where f dash x is also equal to 0. So in part 2 we will be meeting. So till then, bye bye. I will be meeting you in another amazing video.